All right, welcome to The Explainer. Today we are diving into something that sounds like it was ripped straight from a movie script. I'm talking about a real, honest-to-goodness proposal to send a probe to a black hole. And hey, don't just take my word for it. That quote, that's from the astrophysicist who actually proposed the mission, Cosimo Bambi. You gotta love that, right? He's not even trying to downplay how crazy it sounds. He's leaning right into it, which honestly just makes this whole thing even more exciting. So, you've got your interstellar travel, your laser propulsion, your black hole encounters. It checks all the science fiction boxes. But then you look at the other column and bam, it's a real proposal. A speculative one, for sure. But it's based on physics that's actually emerging right now. That line between what we dream up and what we can do, it's getting really, really blurry.
Okay, so let's dig into the plan. Just how bold is this thing? Well, we're talking about aiming for one of the most extreme, most mysterious objects in the whole universe. A place that, up until now, we've only ever been able to see from trillions and trillions of miles away.
And get this, the spacecraft they're talking about, it would weigh less than a paperclip. A paperclip. We'd be sending it on a trip that would take 100 years. Just let that sink in. A tiny, tiny little explorer on this epic generation-spanning quest into the complete unknown.
So you might be asking, why? Why go through all that trouble? And yeah, it's a fair question. This isn't just some cosmic joyride. There's a huge scientific reason for it. This whole mission is basically the ultimate physics test. A way to find out once and for all if what Einstein told us about black holes is the whole story.
And it all comes down to this one concept, the event horizon. So theory says there's this invisible line around every black hole. You can think of it like the edge of a waterfall. Once you cross it, that's it. There's no coming back. Not even light can escape. It's the defining feature of a black hole.
But, and this is the big but, does it actually exist? I mean, really, is it this smooth, perfect boundary that Einstein's math predicts? Or could it be something stranger? This is the central mystery, because we've never, ever been able to get close enough to check. This mission could change that. So here's the experiment, and it's brilliant in its simplicity. You'd send a probe hurtling toward the black hole, and its job is just to send a signal back. Now, if Einstein was right, as that probe gets closer, its signal will get stretched out and just kind of fade away. But if these other wilder theories are right, like one called fuzzball theory, there's no empty space there. There's a surface. In that case, the probe would literally hit something and its signal would just poof, cut out, instantly. Either way we find out, it would completely change physics.
Okay, so the why is massive. It's a game changer for physics. But what about the how? I mean, how in the world could we possibly pull something like this off? Let's get into the blueprint for this interstellar probe.
First thing you need is speed. And I mean absurd, almost unimaginable speed. To make this trip in anything less than 1,000 years, this little craft has to get going at 1/3 the speed of light. That is it's staggeringly fast.
And the tech to do it? It's pretty incredible. It boils down to 3 parts. First, you have the Nanocraft itself, that gram-scale probe loaded with sensors. Then it has a light sail, which is exactly what it sounds like. And finally, the engine, a ridiculously powerful array of lasers right here on Earth, which would basically act like a giant cosmic slingshot, pushing that sail across the void.
And this mission, it's not a quick trip. We're talking about a multi-generational project. It starts with an intense, powerful blast from those lasers to get it going. Then, silence. It just cruises through space for, 60 to 75 years. Then there's the main event, the flyby. And after that, we still have to wait another 20 or 25 years for the data, its final message, to actually travel all the way back to Earth. Wow.
Okay, so as amazing and incredible as all this sounds, we have to come back down to Earth for a minute. Let's be real. This is still a dream, and there are some absolutely gigantic hurdles we'd have to clear before this thing could ever happen. And really, it all comes down to 3 huge challenges. First up, discovery. We need to actually find a black hole that's close enough. Second, technology. Can we really build the lasers and the probes?
And third, maybe the biggest one of all, cost. Who's going to foot the bill for this? And believe me, each one of these is a showstopper on its own.
So let's take that first problem, finding a target. The closest black hole we found so far, it's called Gaia BH1, and it's about 1,500 light-years away. Way too far. For this mission to work in about a century, we need one that's within 20 to 25 light-years. So that's a pretty big difference. Astronomers are pretty sure there's probably one out there in our cosmic neighborhood, we just haven't spotted.
And then there's the money. You sitting down for this? To build that giant laser array, with the tech we have today, it would cost an estimated $1.1 trillion. That is just an astronomical figure. It's more than what most countries spend on everything in a year. So right now, yeah, that's a non-starter.
But here's where a little bit of hope creeps in. We all know how this works, right? Technology gets better and it gets cheaper. If we follow the current trends, that insane trillion-dollar price tag, it could drop to around $1 billion in about 30 years. Now, don't get me wrong, $1 billion is still a ton of money. But it's not impossible money. It's in the same league as other huge space missions. It moves from fantasy to just maybe.
So you take all that in, the huge cost, the fact we haven't even found a target. Is this whole thing just a pipe dream? A fun thought experiment? Or could it actually be a real mission for the future? Well, to get a sense of that, it really helps to look back at how this stuff usually plays out.
Because there's a pattern, isn't there? Back in 1916, Einstein says gravitational waves exist. Everyone says, nope, too faint, you'll never find them. 100 years later, we found them. Then, in the 70s, scientists figure we could maybe see the shadow of a black hole. People say, impossible. 50 years later, we've got a picture of one. The biggest ideas in physics, they just seem to need one thing: time.
Which brings us right back to our guy, Cosimo Bombi. And his whole take on this is just perfectly balanced. He's a realist. He knows we can't build this today. But he's also an optimist. He knows that technology moves forward, always. What seems like science fiction today often becomes an engineering problem tomorrow.
When you really think about it, this whole proposal isn't just about one black hole or one experiment. It's about human ambition. It's about what happens when we dare to ask, what if? It's about pushing that boundary of what we think is possible. And that kind of leaves you wondering, doesn't it? What other sci-fi dreams are out there, just waiting for their moment to become real?